On Christmas Eve, 2024, a spacecraft flew into the sun, not near it, not past it, into it, traveling at 430,000 miles per hour, fast enough to get from New York to Tokyo in under a minute, while surrounded by temperatures hotter than the core of most stars. And it survived. How? That's exactly what we're here to find out. This mission is called the Parker Solar Probe, and that name carries a story worth telling. In 1958, a young professor named Eugene Parker published a paper claiming the sun constantly shoots out a stream of charged particles into space. He called it the solar wind. The scientific community didn't just disagree, they rejected him. 2 peer reviewers dismissed his paper outright. But Parker was right. Dead right. The solar wind is now understood to shape magnetic fields across the entire solar system and drive the space weather that can knock out satellites and power grids on Earth. 60 years later, NASA did something it had never done before: named a spacecraft after a living person. On August 12, 2018, 91-year-old Eugene Parker sat in the crowd and watched a rocket carry his name into space. He died in 2022, but his legacy is still out there, orbiting the sun. The goal was simple to say, nearly impossible to do: physically fly into the sun's outer atmosphere, the corona, and take measurements no spacecraft had ever taken. The problem? You can't just point a rocket at the sun. Earth moves too fast in its orbit to fall toward it directly. Getting close requires slowing down relative to the sun, which takes an enormous amount of energy. NASA's solution: use Venus as a slingshot. 7 times. Over 6 years, Parker made 7 flybys of Venus, each one bending its orbit tighter and tighter around the sun. By April 2021, it crossed into the corona, officially touching the sun for the first time in history. Then, on December 24, 2024, it made its closest approach ever, just 3.8 million miles from the solar surface. For context, the sun itself is 864,000 miles wide. This was close. Dangerously, magnificently close. Here's the part that sounds impossible. The corona is nearly 2 million degrees Celsius. So why isn't Parker a cloud of vapor? The answer is a masterpiece of engineering called the Thermal Protection System, a heat shield just 4.5 inches thick, about the width of your hand. It's built like a sandwich, carbon composite foam in the middle, 97% air, but incredibly strong, pressed between 2 carbon-carbon panels. The same material once protected the leading edges of the space shuttle. The outer surface is coated in white ceramic paint to reflect as much sunlight as possible. The result is staggering. The sun-facing side of the shield reaches 2,500 degrees Fahrenheit. The instrument sitting just inches behind it, a perfectly comfortable 85 degrees Fahrenheit. Room temperature. But the shield is only part of the story. The solar panels are retractable. They fold back behind the shield as the probe gets closer. To stop the exposed strip from overheating, the spacecraft pumps a single gallon of water through them to absorb and dump the excess heat. And when Parker is at its closest point, NASA can't talk to it. The sun's interference blocks communication entirely. So the probe flies itself. 7 sensors around the shield's edge watch for any stray sunlight creeping in. If they detect it, the spacecraft automatically corrects its position. No human input, no margin for error. So what did flying into a star actually teach us? First, the solar wind mystery. We knew it existed, but not how it accelerates to over 1 million miles per hour. Parker found the answer. It happens right inside the corona, in the exact region the probe was sampling. First direct measurement ever. Second, switchbacks. Parker spotted weird zigzag reversals in the solar wind's magnetic field. Sharp flips that nobody had seen up close. These switchbacks appear to play a key role in heating the corona and launching the solar wind. Still being studied, but it's a completely new discovery. Third, the corona paradox. The sun's surface is around 5,500 degrees Celsius. The corona above it, over 2 million degrees Celsius. It gets hotter as you move away from the surface, like a campfire that burns you more the farther you stand from it. Parker's data is finally helping scientists understand why. And why does any of this matter? Solar storms don't just make pretty auroras. They can destroy satellites, crash GPS systems, and take down power grids for millions of people. Every piece of data Parker sends back makes our space weather forecasting sharper. A 4.5-inch slab of carbon foam, 1 gallon of water, a spacecraft that flies itself inside a star. Eugene Parker spent his career trying to understand the sun. The probe that carries his name flew into it. We didn't just touch the sun, we survived it. And we came back with answers that will shape space exploration for generations. The mission is still running. Parker is still orbiting, still measuring, still pushing closer than anything humans have ever built. The sun has kept its secrets for 4.6 billion years. We're finally close enough to take them.